Welcome to our channel Catalyst Modern Day Academic Chemistry. Today we have come with our new video Coordination Entity. We will continue our chapter Coordination Chemistry of class 12. Now, coordination entity is a formation of two substituents, central ion and ligand. And central ion can be of two types, cation and neutral. Now first get an example of coordination entity. Coordination entity or coordination complex is of same thing. We'll get an example and it will be clarified. Just nickel hexaamine 2+. It is a complex. The total complex can be chloride outside the sphere, coordination sphere. About coordination sphere, if you want to know, please see our description box. There is a link given. So now, coordination entity means this part, the ligands or donor groups are bound with the metal ion, and this form an entity, an entity that will give an identification test in the solution also. So in this entity, this is coordination sphere and this is coordination entity. So what is coordination entity? If you have to conclude, the coordination entity of complex, this can be defined as the electrically charged ion or a neutral molecule. So coordination entity can of two type. This is charged one. This is of cation, right? Hence, this can be of anion also. And this is iron tetracyano. This is ferrocyanide complex. So ferrocyanide is of anionic nature and this can be of neutral also. This is nickel tetracarbonyl. So coordination entity can be of three types: cationic, anionic and neutral. So here there is a formation of coordination entity by the combination of the central ion or atom, usually a metal, with one or more neutral molecules or one or more other simple ions. In some case, positive groups can also be found. So this total entity is called coordination entity or coordination complex. Now there are numerous new terms involved here that we have to know. Now there is a new term, it's called central ion, right? So what is the central ion? Just take this example. This is nickel hexacyano complex. Okay, now this nickel hexaamine complex. Now this type of nomenclature, IUPAC nomenclature, will be seen in a video, will be learned in a video, and you will get the link in the description box. Okay. Now in this complex, this is a metal, and this metal, we know nickel is of atomic number 28, and if 2 electron is being given, nickel will be of 2+. And this is a cation. So this cation is somewhat coordinating with ammonia. These are the molecules. They are coordinating. These are neutral molecules actually. So neutral molecules, they are coordinating with 6 ammonia molecules to form this coordination entity. So the central ion is the metal ion or metal atom that is with that one or more neutral molecules. Here it is neutral molecule, and this can be of anions also. It can be of anions will be attached with the help of coordinate bond is called central ion. Okay, while the molecules that are attached with the central ion is called ligands. We will talk about it later in the next video, and that link you will also have in the description box. Okay, now this is nickel, this is of cation, and we will have another one just like this, nickel tetracarbonyl. Another example is of nickel tetracarbonyl. Here carbonyl is also another molecule. This is not an ion, so this is a neutral molecule, and hence there is no net charge from carbonyl. Here nickel is standing on zero oxidation state, that is nickel is here a neutral atom, right? So central ion could be of type cation, a neutral atom. They're very much small, just like vanadium, pentacarbonyl, vanadate ions are there. Vanadium is on -1 oxidation state. This can be of also. These are some actually exceptions are there. These are so much rare we can found. Okay, so now this we can see the central ion or central atom can be just like ions or atoms. So now cation, it is forming, it is right that there are cations. This ammonia molecule are donating their lone pairs, right? Nitrogen have its lone pair, it is donating a cation. Cation already have electron deficiency, so it will getting a help from this type of molecules. This is donating. So these molecules actually donating their electrons, right? Their lone pairs. So they are donating, so they are called donors or Lewis base. Now this is the term we are actually going through a new term, Lewis base. So Lewis base, Lewis acid, these terms will be talked about in another video. You will get the description also there in the description box. Okay, so these are the neutral molecule having lone pair. This is donating, this is forming a coordinate bond. So another type, coordinate bond. What is the coordinate bond and about it, if you want to know, you'll get our video. Okay, so these donor atoms are donating electrons, their lone pairs in this cation. So cation is electron deficient, that's a good thing. But what is here? Here nickel is a neutral atom, so it is not at all electron deficient. So where it is actually accepting the electrons. Actually nickel or here vanadium, we are getting another example as iron. So these we are saying that this is a summary that these are actually d block elements, right? From group 3 to group 12 there are d block elements. So d block elements actually possess a new type of bonding, that is coordinate bonding. So what is their feature that help them to bond this type of bond? This is the d block element actually have d orbital. So d orbitals are this type. This is more expanded than p, so it is accepting electron in their vacant d. Just for nickel, we want to know it is of 28 atomic number, and it is electronic configuration will be argon 4s2 38, so total 28. So there is 2d electron deficient. Why? From 3d0, right? So 3d0, that is a structure of zinc. So this is the fulfillment of 3D orbital, and hence stability will be there. So there is deficiency of 2 electron from 3D10, that is from stability it is getting 2 electron deficient, and so there is actually deficiency, that is vacancy in 3D. So 3D for D block there are 5 orbitals, 1 2 3 4 5, and there are 8 electrons for neutral nickel. So 1 2 3 4 5 unpaired, and this is the thing. So this is actually paired, 3 pair, so there will be no electron accepting here, but there is unpaired 2 electrons. So if electrons are there, so it can accept. Actually it is in ground state. For excited state, it just for frame the electrons like this. So this is vacant, and in this vacant orbital, excited state, in this vacant orbital actually these are accepting electrons from the donor atoms. So nickel or other d block elements can be of neutral or negatively charged or positive, that is electron deficient, as we know from classical thinking. This all can have electrons accepting from the other molecule or ions. So these are acceptor of electrons, right? So the coordinate bond is forming by accepting electrons. So this metal atom or ions are accepting electrons. So these are called Lewis acid or acceptor. So these are the thing we have thought about, we have learned. So in the coordination entity, just we have seen it, this one or this one or this one, and other like these things. So there are actually metal ion, and this is a central ion, central metal ion or central ion, and these are all ligands. Okay, so if the coordination entity, outside the coordination entity, to maintain the charge, we will have another type of ions. Here 2 chloride ions are here, right, outside the coordination entity. So these chloride, or if we want to put something 2 plus, hence if K plus is given, so 2 K plus will be here to maintain the balance, that is potassium ferrocyanide. It is potassium ferrocyanide. So these things, this K plus and chloride here, these are actually called counter ions. So these are counter ions. Chloride or here K plus, this is called counter ions. Okay, so these are the thing we have taught. So now we will have some examples just for exercise. Okay, so here K4FeCN6, that is potassium ferrocyanide. Here the coordination entity is here, that is FeCN6 4 minus. How the charge is being calculated, there will be another video, and you will get the link in the description box. Obviously we will do it in the next video. And the counter ions, this is the potassium, right, outside the coordination entity, so there will be K plus as counter ion. Here the coordination entity is obviously, this is a little bit, so it is chromium hexaamine, it is 3 plus, and 3 chlorides are outside the coordination entity, so chloride will be counter ion. Here for nickel tetracarbonyl, actually the coordination entity is the whole compound or complex. There is nothing, there is no ion outside the coordination entity. This is already a neutral complex. So the coordination entity is here nil. Okay, no coordination, no counter ion. Another example is K2 PTCl4. So this is the coordination entity, that is PTCl4, and K plus potassium is the counter ion. So today we can conclude that central ion and ligands form a coordination entity. Central ion can be of two types, cation and anion. Coordination entity can be of three types, cationic, anionic and neutral. And central metal ion is here with the donor atoms or ligands, we can say. So central ion can be of cationic, can be of neutral, or can be of anionic, that is here vanadium. We are getting three types of metal ion, or rather to say central ion, and these are forming some coordinate bond with this type of donor atoms which are donating its lone pair of electrons. These are called with bases. Actually, they are donating their electrons, and now the central ion having a cation that is electron deficient, or the neutral atom which are having a vacant d orbital. Here nickel is 3d, so here 3d vacant orbital. It is getting electron from the ligand in this vacant orbital, so they are forming actually coordinate bonding. So these are the thing we have read about, and having some examples, we have tried to find out what is the coordination entity and the counter ions. Those are actually here to balance the charge, and these are things we have read about today. Hope you have liked our video. If you like it, please like and share and subscribe our channel, and to never miss a new update, hit the bell icon. We welcome your comments for any inquiry. Our next video will be on the types of ligand, that is density of ligand. Thank you.